Hello guys, so this video is going to be my fifth video in the playlist of data science projects, and it will be my fifth project I'm going to upload on basically fifth or fourth. No, this project will be going to be my fourth project in my playlist of 500 projects. So let's start by mm, creating uh, creating the like environment. So actually I am recording this video at 2:53 a.m. So guys, it's actually dark. I'm using my night lamp, anaconda prompt. I just need to copy and paste this path over here, and this project is going to be really small, because this is not actually a machine learning project, but this is actually like a project of analysis, because I have already told you that analysis is the major part in our data sciences, and um, in every domain of data science, like machine learning, algorithm, or whatever. I've already talked about it so many times. This EDA part is really very important, and today we will be only going to cover EDA. And because there are so many different ways to analyze our data, so I think if you like keep on like and seeing different ways of analyzing different data frames, you will going to learn so much to, like, if you have started your own project to work with, like these EDAs that you have that you are going to watch on my YouTube playlist, they are really going to help you a lot in your projects. So I've already made my environment, because I have already have done with this project. Because only I am going to show you how I think about the like analyzing part, and I am going to tell you how the step by step I have like analyzed the data. So it was activate, and I have given the name it as DSP4, Data Science Project 4. So I'm going to activate. Okay, sorry, DSP4. Enter. I'm now entered in my like environment. Now I just need to type Jupyter notebook. Opening it. So now I have opened it. So this is my Python notebook. Actually, in this project, we will be having two data frames. Um, so this guy keep doing this project with me. This project is not really difficult, because there is no algorithms. There is just like feature EDA part only. But as I've already told you, EDA is really very important, and COVID-19 is really hot and topic for getting jobs. If you are going to put this project in your resume, this will actually going to this project will be your highlight of your personal projects in your resume. So first, let's import the modules. I've actually given all the comments and everything, because I just wanted I just want to perform this project like uh, go through, because if I am I if I do this project like doing this first time, it will going to take me and so many hours. So just guy, please cooperate, because I have already have done with this project. I'm just going to show you how the things are going to work in this project. So first, as always, you need to import these libraries. These all are the must libraries. Okay, so I am going to import pandas as pd, import numpy as an np, Seaborn as SNS, matplotlib.pyplot as PLT, and modules are if I am going to see these modules are imported, then it is going to be like run it correctly. Now it is running because I have completed this project like 29 minutes ago, 30 minutes back. You can see it has actually auto saved it, so it is running right now. Okay, modules are imported. So now, as I've already talked about, like this project will be having two data sets. This one is first and this one is second. So I am importing the COVID-19 confirmed data set. So I have like you know about this read underscore csv, which is a method in pandas. I'm going to import this csv file. Now df.head is like you will get the five rows of your data set. Now run it. So this is our data. Now you can see there are province, state, and country, region, and latitude, longitude, and these are the dates actually. How many cases are there in the countries, and on which date they have how much cases they are having. Like in Afghanistan, there were on on 30th April there were like 2171 total cases. So now we can see df.shape. It is actually going to give us the shape of our data frame. Like we are having 266 rows and 106 columns, like 266 rows, like 266 countries we are having, and 106 columns, like columns are, we have province, country, latitude, longitude. These are our columns. So now delete the useless columns. We have so many two useless columns in this data frame, which are latitude and longitude. We will not be getting any meaningful outcomes from this latitude or longitude from this COVID-19 notebook. So just shift and enter. Now you can see df.head 10. This 10 in parameter actually gives you the 10 rows of your data frame. You can see, as you can see. So these are the 10 rows. Now I'm making now I've done like I aggregated the I aggregated this whole data frame with like country and region. I can show you this. Now you can see it group by actually does like if we have selected some column for grouping our data, they are just going to group that data and making it as a sorry, make it in Sorry guys, actually wait a second, I need to drink water. I actually got the water. Now you can see group by actually does that, like we have selected one column and it is making this as an index of our data frame. So it has make a index, and it is giving this data like an feature. So now you can see we have like 100 uh, 100 100 columns and 187 okay, rows. What we actually have before was like 266 and 104, because of like we were having like none values as well. So aggregating what actually does that, like um, these are the columns are useless for us. These are the columns, and where we will be having like columns like where we will be having like columns like none values. The group by just uh, ignores ignore that particular columns. And you can see there were 102 columns and now we have 100 columns, because they have because group by just column ignored this column, and we and this column is our now index part. So it will not be going to count in this particular rows into columns thing. So now we have 187 into 200 total number of data. I can also see by that 187 rows and 100 columns. Now we need to go forward and doing some analysis part. Now actually I am going to like see the graph of China, how like how by the dates how the COVID cases were increasing. Like in China, there were not peak after this date, like this got to 11 like February 11 February, and after 20th February there were not there were not a peak. The COVID cases were were at flat surface. And in Italy and Spain there were we can see there were a big peak in the month of March. Now you can see I can so we need to find some good measures by a particular country like China. I can see we can like zoom the graph just by firstly we I am going to show you like only the graph of China. By You can select this data frame, and by dot log China, it means you are using this rows data, not column data. By dot log means you are using rows data. I can show you like df this is our data frame, and df dot log viper means we are actually using these rows. We are using rows, rows data, like max speed 4 and shield 5. We are getting this. So same way we are using the cases of cases in on each day, how the cases were increasing. So now let's move to another further graph. In this graph I have actually zoomed it over here, like 3 dot 3 means I have actually covered 3 days of data. Like there were 22, 23, 24. There were it was all the data of January 2020. So I have covered 3 days of data here: 22, 23, 24. Now you can see 22, 23, 24. I actually covered all this data to uh, to get a brief brief analyzation about how the cases were rising on those days. And after and this diff function actually does, like, if we now I will show you the example for this, and for this method. If we have this data frame like PQR 01234, and these are our values, and I actually apply df.diff function over here, then I will be getting this data frame, because df.diff actually does is like it it uh, subtract the uh, first row first row by second row by first row, like, and now you can see row 0 minus row previous. There was not any row above this row 0, so it was null values. So row 2 minus null values is actually null values, so nan. And in second row we are minusing row 1 minus row 0, and row 1 is our this is our row 1 329, and row 0 is our 224. So actually minus 3 minus 2 is 1, 2 minus 2 is 0, 9 minus 4 is 5. Now you can see this is how actually my dot diff function works. So let's get back to our Jupyter notebooks. And in this particular like uh, line of code, it is actually plotting the, like, daily cases. If we are going to subtract the total number of cases, like uh, if we have 20 if we talk about these three days of cases, 1092 are the total number of cases on that day, but and 176 1176 are cases on the 22nd April. And if we want to know about how many new cases were there on 22 April, so for that we need to minus 1279 minus 1176, and that will be our new cases on our 22nd day. So that is the thing I am actually doing on this function. So let me just draw you. Now you can see on uh, it is actually of China. On date like 23 January, there were total number of there 95 new cases were there, and on 24 Jan, there were a total number of 277 number of new cases. I think you got me. So now I need to plot a graph for that, and it is going to be this, like there were a peak on the date around like 2 11 February. So now let's move on. So in this line of code I am actually finding the peak of a particular country, like how how much people were how much people got COVID positive in a single day, like new positive cases in a single day. This one states that. So there were 15,136 cases in a single day, and you can see this one is the peak. So it has automatically find it that particular value. So for the same thing I am going to do with Italy and Spain. I have done already. So there are the same codes. I just put the different country names. So for now, this is little bit tricky, but if you got understand, then it is you will feel good about it, because it is like a little you need to use a little mind for this. Like we have countries and list of different, like now I am putting all the country names in the countries. Okay, now maximum infection rate, I am going to provide it like a single list, empty list. So now I need to find out the maximum infection rate for all the countries. So now for C in countries, C is actually our variable. So C in countries, countries our list of all countries like this, and it will keep on increasing. First I am going to take Afghanistan, then Albania, then Algeria. So take it as Afghanistan and maximum. And now it is first we need to, like, they this is the same function as we have used here. Okay, so it is just going to find the maximum number of cases and in a single day between those particular data. Then it is going to append means, and then it is going to add that number of cases into our maximum infection list, which was empty before. It was after doing this function. So at first it was empty, and then we have put it all the country list over here. Then it is going to append line by line. So now and then it will going to become out like this. I'm just going to rerun it. Now you can see maximum infection rate is like, now you can see maximum infection rate is over this, like 232 is in our Afghanistan and all these countries. So move on. Now I'm going we just need we don't need any other any other columns of these particular data forms. So I'm taking it out our maximum infection rate in a new data frame, which I given as corona data equal to pd dot data frame df abbreviated in this. This is actually our new data frame right now. That is our corona underscore data. So after that I need to import our next second data set, which I've already told you about, that we will be having two data set in this particular project. So now you can see happiness underscore report. This is our name of our data set. So now you can see it is the head of our dataset. I just don't need to write Python here. So this is automatically going to see 5 rows in head function. So now you can see there are like 1 2 3 4 5 6 7 8 9 columns, and overall rank and country or religion score. GDP per capita, social spot, healthy life expectancy, freedom to make life choices, generosity, perception of corruption. It is actually the scores on the basis of these features. Like there are six features for different countries. Like Finland is at the top with the scoring of 7.769. Their GDP per capita income is 1.340, and social support is really high. Healthy life expectancy, like they are living healthy life, uh, and freedom to make life choices, like they have freedom, and generosity and perception of corruption is very low in this country. This is the overall score by these all six features for different countries. So we have like useless columns like overall rank and like score and generosity and perceptions of corruption. These are the things that does not going to matter for the like increase in COVID cases. But these are the things which we will be going to like relate with our maximum infection rate. So let's use those columns: overall rank, score, generosity, perception of corruption, and then we will be going to drop all these columns for our from our data set. As you know, x is 1 is equal to 1 means columns, and x is 0 is equal to 0 means rows. So we are actually dropping our column, so we are using x is 1 is equal to, and in place is equal to 2 means we are actually deleting this from our data frame. If I mark it as false, then it is just going to show us that they have removed from the data frame, but actually they were not going to get removed. So we need to specify true for permanently and delete those columns. So they have already deleted. And now I'm going to set our index as country or religion because it was not indexed before, and in our previous data set which we have made this, we have index as country or religion. Same thing will be having in our new data set as well. So data happiness underscore report head will be this new data set. Now we need to join those two data set we have already prepared. For that, to joining our data set, we need to have same shape of like um, same number of number of rows, and we have 187 number of rows in our corona data that we have previously made. And in our new world happiness underscore report, we actually have 150 100. Okay, what I've done, corona underscore head, actually I want, now I can see. Now you can see it is having 156 rows and they are having 187. To join this both like dataset, we need to have like same number of rows, but if are going to join it with like inner method. There are four type of method to join two tables. There are like left join, right join, inner join, and outer join. So in inner join, the lesser number of rows, and same number of rows will be going to get joined. So for now you can see that they have got joined. Now we also need to check our, like, shape of our. Now you can see, it actually goes 143 because uh, because okay, what do I have, what have I done? Okay, okay. Okay, just wait a minute. What I've done? Hmm. Let me. It was something mistake. I have actually, like, got 143 commas 9 number of columns that. So I have actually paused the video before, and I actually corrected the mistake I have done before. So now let's move on. Now it's all the same. I have actually not done something, not edited something before, but just a little bit um, correction in running my code. So, and now we need to correlate our data. So this is our correlation table. So how is maximum infection rate is like correlating with our GDP per capita income. So it is actually 0.25 related to it, and also these all are, like, healthy life expectancy is really is highly dependent on infection rate. If the healthy life expectancy is like high, then it will going infection rate will be going to be low. So in the next info visualization of the results, we can see the our data dot head. It is like our maximum infection rate, GDP per capita, social score, like healthy life expectancy, freedom to make his life choice. So this is our first graph. We are actually plotting between the GDP per capita and maximum infection rate, and it will be going to, like, this with this, this with this, this with this, this with this. Will be going to make all these graphs, and now you can see. And I have also made like regression plot, which will be making a, like, uh, a slope between the data. It was a scatter plot before that, and I was actually doing using a log method to normalize our infection rate, because these are in our 0 point in terms of like float values. So I am going to normalize our infection rate by using log method. Now you can see, if like take this country, and if the you can read, like, if there is less number of infection rate, it means their GDP per capita income is also very less, and in the countries where infection rate is really high, they are also having GDP per capita income is high in there. So these are some graph as well. You can read it by yourself, because, like, um, if you read as maximum graph as you can, that will going to broad your mind, like in reading the graph and visualizing things. By that you can easily uh, do such kind of analysis by yourself. So I think there are two more graph left. These are the same. You just need to read this graph and make some make some analysis for your company or whatever. If you are going to in healthy sector, these things are really going to matter. Like how you can analyze the data about different cases. If you now this type of analysis are going to help in vaccination process as well, like how we will be having different kind of features for vaccination, like how many people got infected with got like uh, what we can say after vaccination there are probably going to be chances of some infections or like some kind of problems, or what can we say, the doctors are going to make some features or on that part, and they are probably going to study those things and will going to vaccinate by the age, also by the ages. And there are so many features I can't really explain these things because I'm not into medical field. So okay guys, bye bye. This project was very short, and please guys, let me know in comments if you will love to see these types of project as well, like analysis project, or you want to see some machine learning project. But I know machine learning projects sounds cool, or it looks cool to perform some predictions for something. But analyzing random data is also really fun. If you are going in data science field, it is actually really very important. So I think that's it, guys. Bye bye. And this is my fourth project video, and there will be lots of more. So bye bye, guys. See you next video. Bye bye. Take care.